have figured it out. So again, I posted that the other day on Facebook and Twitter. I'm pissed with myself. I now it's not the fault of the tool again. It's just the fact that I was just wondering why is it not working with control rotation with CRZs? And then I kind of realized if you just go here and take a look at the stuff, see if that works. So you kind of see that, well, really, and you gotta go down here. Actually, this is the actual gate that I want to use, and then I kind of coming back to just whatever. I mean, going back to the actual, I just went back to the QFT page in the IBM Q Experience, and I realized that the whole time, the whole time, it was just in front of my eyes, um, and the U gates are used. The U1 gate is used, man, and those things here, they are just the control use. And then I realized, oh, CU1. Okay. So once you play with this a little bit more, you realize that that with the control rotation flips also attaches also the face on the zero component, and that was creating the wrong effect. So, and this is really what I wanted to do. So let me just clear that up a little bit. Here. So what I wanted to show here, what I was trying to build the other day is I was trying to build how could we implement a phase kickback effect that is sort of used in Schur's algorithm. And just to make a small example, to refresh what I wanted to do is here. So this part, right? You have to imagine this is your modular multiplication. That's kind of what you do in Schur's algorithm. So instead of doing that, because I don't know how to do that yet, let's assume that's the outcome, which is like 0, 1, 1, right? So 3. And then basically implement Z rotations from each of those qubits up to another qubit here to encode that value in the face of a superposition. And so, sorry, I just messed up exactly here. So what I wanted to do is I wanted to get rid of the qubit 1. I know I can do that. Whatever. I mean, imagine that's a superposition. You can have multiple qubits in here. At the end of the day, that's what you want to do. You want to have multiple qubits. It's just that I can't grow that easily more. And then if you can see here in the visualization, maybe let me just get rid of this. So I show you. So you see that it's kind of reddish, right? If I would kind of start with 0, so 0, 0, 0 we've got here, then it's blue, right? So you have to take a look at the one that has the 1 component, okay? The 0 component stays the same. That's the idea. So if I now add a 1, basically that turns into so now it's going into the yellow direction. Because remember, the half rotation is here, so it's 4. And it's kind of yellowish, right? So that's the idea, is 4 is the half of 8. So if the answer is a 4, then we should have a phase that rotated half the way, and that's how you do it. So the parameters are pi here, pi divided by 2, and pi divided by 4, because of sort of these are the inverse of the powers of, right? Because it's the parameter should be relative to sort of the power of that qubit, like the influence that qubit has in the whole number. Remember, if you have 3 qubits, you can go from 0 to 7, so you can represent 8 numbers. And so you want your 7 to be almost a full rotation. And so if we do here like that, it's almost a full rotation, right? So it's kind of purplish. If now that would overflow and you would have an 8, so you would literally have another qubit down here with a 1, and those would be 0, because that's how the 8 is represented. Then you are blue again. So you're kind of literally 8, like 8 is 0. Right, in this case. So and that's basically how you do it. So it's this is the phase kickback thing here, and so you're rotating here, right? So you're not affecting those qubits either, but then the phase is encoded in your superposition. So the reason I had two here is because I wanted to play with the idea of, so what happens now, just so you could see what you would do, like if you would say, this is a one, right? And now I want to have the same thing, but with the next number two, just to kind of see that there is sort of the color is changing. And so I wanted to copy all those three here, but then change those to one, right? So they apply to this superposition, to this qubit, and then I don't know if this does this zero things. I hope so. I wanted to zero those. Yeah, it kind of resets the qubit, but I think that that's dangerous to do, because I don't know if that has any effect on this qubit. So let's assume that, let's not touch that qubit. Let's assume that's one, and here I want two. So I'm just gonna add another X here and an ID here, because I already have that to one. So you know what I mean? So this is basically one, and this is basically two, right? And this is encoded. The two is encoded in this qubit phase, and this is encoded in this qubit's phase. So if we take a look at now the visualization, and you take a look at the, so you have to forget about, let me see, I can zoom in. Forget about these and forget about these. So this is literally, you need to just, because those are the zero components respectively, right? Or not. So I want to have, that's complicated to see. You see, I can't see that because with multiple qubits, the phases now here, like you can't see that because here you've got a, so the case in which the qubit 0 is 1, right, is this one, but then the case in which the qubit 1 is 1, it's split between this and that. So those phases would kind of have to be added, I think. And I can't add the colors because I cannot figure out the phases here. But you see what, my point here is, the idea is you do that repetitively for more qubits, but if I add more qubits, then simply, that doesn't work anymore from 6, 7, 8, because I cannot see the colors. So the tool becomes useless at that point. Because if I add all these, right, I could literally move those things. I could literally move those things. That's wrong. So let me just. So you could literally basically have your superposition encoded here, and say, I want to use a 4 qubit superposition, and then kind of do from qubit 4. So the first ones would be This is just a bit messy, a bit cumbersome, but so this would all be on qubit 4. Qubit 4, and then they would, no. So what is the target actually? Which is this one, pi divided by 4, 4 and 7. No. So this is, so this would all be, for example, qubit 0, qubit 0, qubit 0, and then this would be like 4, 5, 6, right? And I mean, I can even go, I can even go farther and say, I'm gonna add more resolution to that. I'm gonna say I'm gonna go to qubit 7. That's pi divided by 2. That's pi divided by 4, and that's pi divided by 8, and then kind of have that copied over for basically 1, 1, 1, 1, kind of forgotten H, Q3, and exactly, and then you get the idea, right? So you can do that and then go like 2, 2, 2, 2, and then do even like 3, 3, 3, 3. So what you're doing is you're kind of encoding those numbers to each of those superposition elements in the superposition. So this is your superposition, and this would be like, if you are really, let me see if I can open up Jonathan's phase estimation. Yeah. Bum, 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 bum. Exactly. So this is what we're building. Yeah, this is really what we're building. So you see that first register is the one here that I marked, and then these different operations is what kind of you're doing here. It's just, this isn't a really basic. So what you would do here is let me make up that we have a subroutine, right? That is called I don't know, UP, like, or just U, right? No, or like the module, the mod thing, kind of whatever. So this is, sorry, and the mod, and it's kind of has param1, param2, param3, param4. I think I can do that, yeah? Can I? Or it's going to break again. I don't want the parameters. I'm sorry. I want Q1, Q2, Q3, Q4, and then that's what it does, and then that's what it does exactly. So what you want is you want those. So you want those operations to be implemented, and then oops, here I missed. I think this would be 3. So this is what you want to get, what you kind of want to implement, right? So each of those boxes would then make whatever operation, and then the output is the result. And I think the problem is that this is a bit unrealistic, the way that I'm drawing the circuit here right now, because you cannot just simply reuse them. So you either need a lot of qubits because you need to add 4 more qubits for each operation, or you need a mechanism to you probably need to undo this, right? So you need another subroutine that is kind of like maybe called inverse or inf mod, right? And so what you do is you kind of clean up this information. I don't know if that's the right way to do it, but intuitively that's the idea, right? And then what you end up is, if you just read that superposition, so you're gonna have that. So the problem is it's nice but I can't see that. The thing is, it's so big because there's so many already qubits that the visualizations don't work. But the idea is like each of those elements and your, see if it's here. It's not here. Kind of. I think it's not here. Photo. Each of your. I'm trying to go to try to find his main. The sort of the first article. The first article where he shows all the modular. So that's okay. So he's sort of in a schema of like what I'm saying, right? So you do that in different steps, and then you do that. So this is a way to build the modular. I'm gonna do this in the next video. So I'm gonna try to explore that in the next video. But I think that's the rough idea. So you kind of get it. I mean, I hope that it's clear enough. That was supposed to be really just intuitive, right? Intuitively speaking. And so with Quirk, you kind of got that. Let me clear this. You kind of got it a bit built in, right? Because you have those parameterized gates in here. They basically do that. So it says it rotates the target by input A divided by 2 to the nth of a half turn around the z-axis. But I don't know why it's in the half turn though. Where n is the number of qubits in input A. So that's the idea here is you prepare your superposition, bum, 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 and then you prepare an input A, where you kind of say, good, so this is my input that has 3 qubits, right? I'm going to place it here. And I want this input to rotate that. And then I have to find a way to shortcut. I think I have to read the manual because it's pretty powerful, this whole thing here. So I think then I can have another input A, which maybe I can just reuse and do something in the middle, but like I want these to then, do that here. So you kind of build it a bit in a different way, but essentially it's the same. So the input here is, I think you can default it, but I don't know how that works. If I can say it's 1, does this work at all? Can I just say like, so it's a 1. Okay, but you kind of, so it's a 1, and then I'll say here, can I just destroy it? I cannot 0 that, right? So I probably have to add another x here to do a 3, and another x to do a 4. So what I wanted to show is which are the ones that matter though. Oh, can I just put a chance sample density matrix, chances of outcome measure was performed, amplitude display. How can I see the because here I can see the exactly. I just wanted to see from these guys. I don't know if I can. How can I read that? Maybe this, then this, and then this. I think those are the 3 that you should see. Correct? Because I don't know how to read that here, but that would be the idea. So here you see the phase is rotated. What if I think that's because I don't know which one is considered the which one is considered the which one is considered the I don't know how to fully read that though. What if I just say amplitudes? No, that's what I'm doing. Chance. How does it work if I do that? Because that only shows me the chances, so that doesn't show what I want to see. I want to see the. I think that was the right. That's the right thing to look at, but I don't know. I know there's a neat way to visualize that. Because in my okay, this, 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 face. Maybe it's easier to visualize if I use separate. Because I think that's the problem is the reusing thing. So I wanted to do a 1, I wanted to do a 2, and a 3. Right? So now I got this. How can I read that? Anyway, I'll figure it out. I guess I'll figure it out. But that's kind of the idea. So you're rotating the face based on that input. 0, 0, 1, 0, 1, 0. I guess because I would have to aggregate some of those faces for this to really be. Yeah, anyway, but you need probably here much more, and then many more of those. You need a bigger superposition to kind of be able to see the full cycle, and then once you see the full cycle, because then you apply the QFT, and then you can read the phase. You can read sort of the period, the period of the frequency of that encoded wave, right? So that's kind of the essence. Okay, so that's step 1. Once that's clear out, I'm gonna in the next video I'm gonna try to make that work, and then kind of in this tool, because I think it's better to use this tool, because here I can't see anything. Here I sadly have hit the limitation of the tool. And yeah, cool.